Okay, let's give you guys some practice. So here, integrate this. So in the future, you'll be given something like this, and then you have to decide for yourself if you should use integration by parts, or if you should use substitution or trig substitution. You have to decide for yourself. But currently, because we are at a stage where our integration skill is still weak, I'm going to guide you through this thing. I'm going to tell you to use substitution and then use integration by parts. So you've got to combine the two. Okay, so use substitution and then use integration by parts in order to integrate this. So press pause and have a go. Okay, so to do this, let w be this thing here. So let w equals root of x. And then now, when you let w equals root of x, you might be tempted to do this. So now you might be tempted to say, oh, dw equals, and then you differentiate this, which will be 1 over 2 root x. Okay, so if you don't know this, then, well, you should by now. If you differentiate this, and then this goes down and blah blah, it will give you this. Okay, so when you say let w equals root of x, you might be tempted to say, oh, then dw equals, differentiate this, and then dx, and then dx equals 2 root x dx here. And then now you might be, sorry, dw here, and then now you might be tempted to just put this back into here. But you see here, you've got this square root of x lingering around. You want, when you make substitution, you want everything in terms of w. Here you've got the square root of x lingering around. So you might be tempted to go this root here, and then, but then the thing is, you've got this square root lingering around. You don't want the square root of x. You don't want things in terms of x. There's nothing over here to cancel out with this x. So when you make this this substitution, from here, square both sides, so you have w squared equals x. So now you could say you could differentiate it, d, and then dw here, and then here you would have 1 dx. So now you can put this into the dx here with no x lingering around. Okay, so now let's try and do it. Put this into here. So this thing here will become sine, and then remember this here is w. So w, and then dx is this thing here. So we can then put it into here. So that will be 2w dw. You see, now this here is a constant. Take it out, and then rewrite this, and it will give you this. It will give you this. Okay, because the 2 here is a constant, so you can take it out, and we're just moving the w in front of the sign. So now it looks like this. So when you are now currently at this stage, hopefully you are at a stage where you should realize that this is, you've got one block here timesing another block here. But then if you differentiate this block, it would, hopefully when you get to this stage, hopefully you can recognize that you should use integration by parts now, because when you differentiate this, it becomes, well, hopefully if you get to this stage, realize that you've got one block multiplying another block, and here you should you should have a gut feeling that you should use integration by parts. Well, okay, let's now try and integrate this now. So remember, we still got the 2 in front. Okay, so now use integration by parts. So we are trying to integrate this. So this here is a formula for integration by parts, and this here is a mistake. Hang on, because we are doing everything in terms of w now. Hang on, we are integrating everything in terms of w. So bear with me. And then so now we are trying to integrate this now. So let this be u, and then let this block here be v prime. v prime. Well, if u equals w, then u prime equals 1. If v prime equals sine of x, sine of w, if v prime equals sine of w, then normal v would be us integrating this thing here. So integrate it, it will then give you this. Now just blindly follow this part here. It's saying get u times v. It's saying get u times v. So that would be, oh, don't forget you still got this 2 here. So that would be, hang on, let me put this 2 in here. So it's saying get u times v. So get u times v. So that will be minus w cos w here. And then you've got your minus here, minus the integral of, well, it's saying get u prime times v. It's saying get u prime times v. So that's just this, cos w, and then here you've got dw. Okay, so this whole thing here will then become this. Okay, so now you've got a negative 1 here. It's just a constant. It's just a constant. So take the negative 1 out. So that will then give you this. And then now this is straightforward to integrate. So integrate that. It will give you this, and then plus a constant. And then it's and then earlier we said let w equals root x. That's what we said earlier. So now we can put this into here, into here, into here, and so on. So that will then take you to here. So this here is your final answer. Okay.